Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of P1 variant 1-2 of June 2020. And for this, I am using the work of an outstanding and one of my best student, Miss Sabah Bilal Kamar of class 2022, the Lyceum. Well, all these instructions are very important, especially this last one. Give non-exact numerical answers correct to three significant figures or one decimal place for angles in degrees, unless a different level of accuracy is specified in the question. Must follow these instructions. An important advice for me and for everyone: we should be kind and we should be humble. Two important tips to solve the paper in a good way. Number one, read the questions carefully. Number two, avoid careless mistakes. Question number 1 part A. Find the coefficient of x square in the expansion of. 1 part B. Find the coefficient of x square in the expansion of. C. This same expansion is used in the later part. Therefore, we will expand this expansion to get the coefficient of x square in part A, because we will use this expanded form in this later part. And always expand the expansion one extra term. So see, this term will give you coefficient of x square. By I expanded this expansion till this term, one extra term. So by expanding this expansion till the fourth term, we have this x6 minus 12x4 plus 60x square minus 160. This is the coefficient of x square, positive 60. And I will use this expanded form here. This will make this later part very simple. Therefore, I substituted this, the result of this expansion here, and then we just need to multiply these selected terms, the terms which will give us the requirement, that is the coefficient of x square. So when you will multiply 2 with this, you will get a coefficient of x square, which is 120. When you will multiply this term with minus 160, you will get minus 3 times 160. Hence, the coefficient of x square is negative 360. Important tip: always expand the expansion in part 1, because the same expansion is used in the later part, and to make the later part simple. Next question. Express the equation as a quadratic equation in sine theta. This is so simple. You just need to replace tan theta by sine theta upon cos theta. Then do cross multiplication and then replace cos square theta by 1 minus sine square theta, because the identity is sine square cos square is 1. This is the required quadratic equation. Hence, find the acute angle in degrees for which 3 cos theta is 8 tan theta. You just need to factorize this. When you will factorize this equation, you will get this equation. And there are two values of sine theta. You know, sine theta always lies between minus 1 and 1. So this value will be rejected. This is in first quadrant. They ask acute angle. For acute angle, sine must be in first quadrant. All function must be in first quadrant. This is the answer up to 1 decimal place, 19.5. You don't need to write this answer. Just write the acute angle. Question number 3. A weather balloon in the shape of a sphere is being inflated by a pump. The volume of the balloon is increasing at a constant rate of this 600 cm3 per second. This is dV upon dt. Increasing means positive. The balloon was empty at the start of pumping, meaning volume is 0 when t is 0. Find the radius of the balloon after 30 seconds. So you just need to use ratio method for that. Number 1, get the volume for 30 seconds. So 600 cm3 in 1 second. So in 30 second, volume will be 18,000. Now by using this formula of a sphere, we can get the value of r. First get the volume for 30 seconds and then use this formula for the value of r. This is the volume of a sphere. Now by using chain rule, we can get the rate of change of radius. This is the chain rule with respect to this formula. dv upon dt, dv upon dr, dr upon dt. You all know how to form the chain rule according to the given formula or situation. So we just need to differentiate this volume with respect to r, and then we need to substitute this value of r here. That's the dv upon dr, numerical value of dv upon dr. By substituting this value here and 600 here, we can get dr upon dt. Make sure you give your answer up to 3 significant figures. This part is important, especially this part. Question number 4. The nth term of an AP is this. This is Tn. So by using the formula of Tn here, which is a plus n minus 1d, and by comparing the coefficient method, we can easily get a and d. Or we have choice. We have other method as well. The other method is very simple, which is this. Get the first term. So it should be 3 minus 15. I think the first term is negative 6. This is the easiest way. The second term would be 6 minus 15, which is minus 9 minus 4.5. Therefore, d will be t2 minus t1, which is 1.5. This method is simple and easy. So you have two options. Either use this method, which is the best way, and this method, which is the comparing the coefficient method. This method is a bit difficult. I would prefer this method. Use this method. Both methods are fine, but this method is simple. So we have got the first term and the common difference. Find the value of n for which the sum of the first n terms is 84. Now we need to use the formula for Sn. This is the formula of Sn, and we have the value of a, we have the value of d, we just need to work for n. And the value of n is positive 16 because n is positive integer. Minus 7 will be rejected. You should show the breaking of the middle term, or you should show the quadratic formula here. Don't write this answer directly. Either show this quadratic formula or show the show the breaking of middle term thing. I'm leaving this for you. You can do this yourself. Question number 5. This is the function f. Express f, which is f2 basically, and f inverse is simple, f2. We find f2 by replacing the x of f by f. We just need to replace this x and this x of f by f. This is f, this is f2 or f of x. Inverse is simple. We just need to replace this f of x by y here. Then we need to make x subject, and then at the end we need to replace x by f inverse and y by x. Now we need to solve this equation. This is simple. So we need to find x in terms of a. So by solving this equation, we have x is a upon 3. Question number 6. The equation of a curve is this. Given that the line is a tangent. Tangent means b square minus 4ac equals to 0. So we just need to equate these two y to get the quadratic equation, And then by substituting the values of a, b, c into this discriminant, we have k, 6. It is now given that case 2, express the equation of the curve in this form. This is the completed this square form. This is so simple. We just need to substitute k2 here, and then we just need to compare this equation with this form. By comparing the coefficient method, we have the values of a and b. A is half, b is half. Make sure you will substitute a and b over here. So this is the required form. So always solve this part by comparing the coefficient method. That's the answer. In the diagram, OAB is a sector of a circle with center O. This is the center of this arc and radius 2r. Angle AOB is pi by 6. Show that the exact length of BC is this. So in this triangle, if we use cosine rule, we can easily prove this. So by using cosine rule in this triangle, we have OC square, which is r square, and then 2r square minus 2OC OB cos pi by 6. So by simplifying this, we have 5r square, 2r square, negative 2r square root 3. This is BC square. By taking square root on both sides, we have this. This is what we had to show. Now we need perimeter of the shaded region. Perimeter means sum of the boundaries of the shaded region. So we need these three boundaries. R, this is also R, because let me check this, if this is R or not. We need, no, this is BC, so this is not R, this is here. And this is the arc length. So perimeter is this R, BC plus arc length. This is R, this is BC, and this is R. So AC is R, BC is here, and arc length is R theta. That's the answer. Now we need area of shaded region. This is simple. Area of shaded region will be area of sector minus area of this triangle. So area of sector is half 2r square theta. The radius of the sector is 2r. Make sure you replace this r by 2r. This is general formula. Theta is pi by 6, half AB sine C. You just need to simplify this carefully. That's the answer. Next question, number 8. The diagram shows part of the curve y is equal to 6 upon x. This is the curve. The points 1, 6 and 1, 2 lie on the curve. The shaded region is bounded by the curve and the line y2 and x1. This is the shaded region. Find the volume when the shaded region is rotated 360 degree about y-axis. So this is simple. You just need to do this. Volume generated by this curve minus volume generated by this line. First you need to make x the subject. When you will make x the subject, you will get 6 upon y. It's here. So volume under the curve rotated by the curve and volume rotated by the line. Curve pi limits, make sure you take the limits for y-axis 2 and 6 of y-axis. This is the equation of curve. Square this, write dy. This is the formula for volume of rotation. It's here. This is the volume rotated or generated by the line when the line is rotated 360 degree about the y-axis. You just need to handle this integration carefully. This will become 36 y power minus 2. When you will integrate this, this will become, let me clear this. This is 36 y minus 2. When you will integrate this, you will get 36 upon minus y. Now you just need to apply the limits and give your answer in terms of pi. Next part. The tangent to the curve at a point x is parallel to this line. Number one, draw this line. This is here, y is equal to minus 2x. And tangent to the curve at x is parallel to this line. This is the tangent. This is the tangent to the curve at x, which is parallel to this line. So the gradient of tangent must be minus 2, because the gradient of this line is minus 2. Find the coordinates of, number one, we need to work for the coordinates of x, and then we have to prove that x lies on this line. First, work for coordinates of x. And for that, we need to differentiate this equation of curve and equate gradient to minus 2. See, by differentiating this equation of curve, we have dy upon dx, minus 6 upon x square. Now, by equating this gradient to minus 2, we have this here, x coordinate, because gradient of tangent is minus 2. This is dy upon dx. So by equating this to minus 2, we have x under root 3. By substituting this root 3 here, we have y, 2 root 3. So the coordinates of x are root 3 and 2 root 3. Now we just need to check whether this point lies on y is equal to 2x or not. We have to show, in fact. So we need to put this point into this equation. So 2 root 3 is equal to 2 root 3 shown. Number one, work for the coordinates of x by equating this gradient to minus 2. Get the coordinates of x, this point x, and then substitute this point into this equation. This equation must be verified for this point, hence shown. Next question. This is question number 9 of transformations of functions. Functions f and g are such that we have trigonometric functions. State the ranges of f and g. So by comparing f with this standard equation, we can get the range of f. The range of f will be this minus 1 to 5 inclusive, because c plus a is minus 1 and c minus a is 5. So minimum value is here and maximum is here. Minimum is minus 1 and maximum is 5. Now for the range of g, you just need to observe g. G is negative 2 times f of x. You just need to multiply this with negative 2, and this is also by negative 2. So when you will multiply this with negative 2, you will get 2. When you will multiply this by negative 2, you will get minus 10. So the range of g is minus 10 to 2. Or you can get the range of g in this way. First get g. G is minus 2f of x. Now work for c plus a and c minus a. C plus a is 2 and c minus a is negative 10. So the range is minus 10 to 2. You have both the options. You can do in any way. Now we have to sketch f of x. Sorry, we have to sketch g of x. This is g of x, and the range is minus 10 to 2. So this is minus 10, this is 2, and the mean line is minus 4. This is the mean line. You all know how to sketch the trigonometric functions. This is the sketch of g of x. The range is minus 10 to 2, and the mean line is minus 4. Make sure your sketch g of x must cut x-axis here. Next part. This is h of x. gx plus pi for this domain. Describe fully a sequence of transformations that maps f of x onto g of h of x. So this is very important. We don't have any relation which will transforms f of x into h of x directly. Listen, first f of x will transform onto g of x, and then g of x will transform onto h of x. This is the sequence of the transformation. First f of x will transform onto g of x, and then g of x will transform onto h of x, because we have a relation of h in terms of g. We don't have direct relation of h in terms of f. So we have to do this in this way. So f will transform onto g with this transformation. It's here. And this negative sign means reflection in x-axis. And this 2 means vertical stretch factor 2. Now this g will become h with this transformation. It's here. And this pi means translation vector minus pi 0. Make sure you write the correct sequence of transformation. There is no relation of h in terms of f, and we have to explain f in terms of h. We have to explain the sequence of transformation, describe the sequence of transformations that maps f onto h. And we don't have direct relation of f in terms of f and h. We have the relation of h and g, and we have the relation of g and f. So write in this way: f, g, h. First f will transform onto g, and then g will transform onto h. So in this way f will transform onto h. So you just need to explain these transformations. This negative sign means reflection in the x-axis. This 2 means vertical stretch factor 2, and this plus pi means translation minus pi 0. So first reflection in x-axis, followed by vertical stretch factor 2, and then followed by translation vector minus pi 0. This solution is very important because this question is very important. So please take the screenshot of this solution. This is the right translation vector. Make sure you will write this vector. Question number 10. The equation of a curve is this. We need dy upon dx and second derivative. This is so simple. You all know how to differentiate the simple function and linear composite function. 54x will become 54. This 3 will become coefficient, and in power it will become 2. 3 minus 1 makes 2. And the differential of this bracket is 2. This is the simplified form of dy upon dx. When you will further differentiate this, you will get the second derivative. Find the coordinates of the stationary point. For that, you need to equate the first derivative to 0. By equating dy upon dx to 0, we have x2 and 5. By substituting these two values one by one into this equation, we have the values of y, 243 and 135. Determine the nature of each of these stationary points. For that, we need to use the second derivative, and we need to observe the sign of second derivative at these two particular values of x. At x5, the second derivative is negative. So this point is maximum, 5, 243. And at x2, second derivative is positive. So this point, 2, 135 is minimum. Next question, 11. The equation of a circle with center C is this. Find the radius and circle and the coordinates of the center. This is so simple. By comparing this equation with this standard equation of circle, we can get both the radius and center. Center is at minus g minus f. So the coefficient of x is 2g minus 8, and here coefficient of y is 2f 4. So g is minus 4, f is 2, center is at minus g, so plus 4 and minus f means minus 2. Radius, this is the formula for radius. G square f square minus c under root. Radius is 5. The point 1 comma 2 lies on this circle. This is 1 comma 2 and this is the rough sketch. Show that the equation of the tangent to the circle at P is this. We need to show equation of this tangent. For that we need to first find gradient of this radius line CP. Gradient of CP is minus 4 upon 3. Therefore gradient of this tangent will be 3 upon 4. We have the point, we have the gradient, we can easily get the equation. This is the equation of tangent TP or this tangent. The point Q lies on the circle and PQ is parallel to the x-axis. Q should be here because PQ is horizontal. Write down the coordinates of Q. This is so simple. See, since this is the horizontal line, so the y coordinate of P and Q, y coordinates of P and Q will be same. The y coordinate is 2. And x coordinate is also very simple. This distance is 3 units because this is 4. This number is 4. This number is 1. So this distance is 3. So 4 plus 3 makes 7. See, therefore the coordinates of Q are 7, 2. Let me repeat this. See, this is the horizontal line. On horizontal line, y coordinates remain unchanged. The y coordinate of P is 2, therefore the y coordinate of Q is also 2. Since the x coordinate of C is 4, therefore this should be 4. This is 1 because the x coordinate of P is 1. This difference is 3. So 3 plus 4 makes 7. This is 7. So the coordinates of Q will be 7, 2. The next part. The tangents to the circle at P and Q meet at T. This is T. This is the tangent at Q and this is the tangent at P. So by solving the equations of these two tangents simultaneously, we can get the coordinates of T. We have the equation of this tangent. We need to work for the equation of this tangent. And for that, we need to first work for the gradient of this line CQ. First, get the gradient CQ, then form the equation of this tangent, and then solve these two equations simultaneously for T. Here is the solution. This is the equation of tangent at Q, and this is the equation of tangent at P. By solving these two equations simultaneously, we have T, which is 4, 17 upon 4. You can take the screenshot of this solution if you want. An important advice for me and for everyone: we should be sincere to others. Good luck. And I'm extremely thankful to Miss Sabah Bilal Kamar, who helped me to make this lecture. Indeed, she is an outstanding student. May Allah Pak bless her always. Ameen. May Allah Pak give her the best grades. Ameen. Allah Hafiz.